So welcome back to what is now a 4-part series on end-user computing. My name is Paul Murray. I'm a solutions architect at Nutanix in Northern Europe. And in today's session, today's webinar, we're going to be talking about sizing and everything you need to know, everything you need to understand to successfully size a Nutanix cluster for your VMware or Citrix virtual desktop deployments. So it's all about understanding the use case. Now, when I talk about use cases, what I really mean is groups of users or a grouping of users with similar requirements. Why these matter for sizing, for a correct sizing, is to be able to identify commonalities. So identify desktop requirements such as CPU memory, I/O capacity, storage, and the like. To be able to identify operating system requirements, whether it's a specific version of Windows 10, the application sets, the application usage of your employees, differences whether it's persistent, non-persistent, or whether those applications, whether those employees have got graphical requirements. So these matter for infrastructure sizing, because if I have the ability, or if I can group these together as a certain use case, then I can create a sizing specific for that application set, or a sizing specific to those desktop resource requirements. So they are important because they allow us to create a more accurate sizing, which in turn results in a better model selection. So a better selection of the nodes that build that Nutanix cluster. Some of the stuff that we need to consider, so some of the data we need to collect can be done with, we've got our own tools, but that's a collector, RV tools, for example, that's more around the infrastructure. So that's going to tell you what sort of machines you need to be able to run a virtual desktop. But what it doesn't say is it doesn't say what that actual desktop is doing. So we need to understand what the users are actually doing with those desktops, what they're doing with those applications. We can do that with various tools. So Liquidware, Lakeside, Perfmon. There's also a GPU profiler from NVIDIA, to name a few examples. So these are tools that you can use to understand what the user is actually doing in that desktop. We then need to look at the data that needs to be collected. So obviously memory usage, CPU usage, the GPU consumption, disk capacity, Windows versions, Office versions, and if possible, your application list. So all the applications that those employees are using. Now, going back to when I used to work at Citrix a long, long time ago, I've heard of companies that have got thousands of applications. They would use VDI as an opportunity to be able to reduce the number of applications and also to be able to create these application lists. So talk to the admins, talk to the desktop admins at those customers, and they probably have some sort of grouping of these applications and the users. Other components that can affect the sizing, so the differences between the OS versions, so Windows 7, Windows 10, also the differences between the Windows 10 build numbers. A few slides later on that describe or explain or highlight some of those differences. Office versions, Spectre, Meltdown, and ForeShadow, whatever it's called. Okay, probably not relevant today, but I'm going to use that as an example of what can affect a sizing. So memory configurations, memory speed. So again, differences between architecture. So the NUMA stuff has changed from dual channel to triple channel. So you're seeing configurations there where we have what people would often think to be an oddly sized memory configuration. So again, we need to understand the architecture being used, GPU, non-GPU, things such as CPU bound. Again, talking about the applications. Some applications are not really multi-threaded aware, so still single-threaded, so they can't take advantage of multi-threaded applications or multi-threaded CPUs. There are other applications that are CPU frequency sensitive. So just throwing a faster CPU at that application or at that program or that process is going to make those applications faster. So again, understand, are those applications CPU bound? Are they single-threaded, multi-threaded, stuff like that. And then often what's overlooked is the actual infrastructure to be able to run your VDI solution. So things such as the SQL databases in the Citrix world, talking about storefront servers, the DDC, so the brokering components, and then when it comes to security, so NetScalers, load balancers. So obviously the infrastructure, like I said, to be able to run that VDI deployment. We have some assumptions, and again, these really are just assumptions or starting points. So we've got ours, they're basically taken from the vendor best practices, so from Microsoft, from Citrix, from VMware. We categorize that in a similar fashion, so task workers, office workers, knowledge workers, and power users. So not going through all the differences, but ultimately that ends up in different requirements. So again, like I said, we have 4 sort of preliminary signs. It's a good starting point. So task users, sort of 1 to 2 CPU, office users, same sort of vCPU configuration, but more memory, then through to knowledge workers and power users. Where this becomes important, I'll show you later on, when it comes to selecting the number of vCPUs for your standard virtual desktop. We also have recommendations when it comes to the user density per node. So this is based on internal performance testing. The recommendations we got there, so the workloads per node would be for task users, maximum of sort of 160. If we look at the power user configuration, so sort of keeping that to maybe 80, 85 users per node. So again, just recommendations about the user density that we can achieve with these nodes. So the effect of the virtual CPU count on desktop performance. Now, I've spoken to a few customers over the years where they all have their own definition of what they consider to be a standard desktop. I've seen examples of 4 CPU, 6 CPU, or 6 vCPU, or 8 vCPUs. That's their standard Windows desktop. So Windows 10 desktop with 8 vCPU. That's a bit of overkill. Now, when I come along to a customer and say, okay, we don't need 8 CPUs, let's start with 2 vCPU. The first question they often come back with is they just do not believe that 2 vCPUs is going to be enough. So what this chart is describing is the difference between adding virtual CPUs to your virtual desktop and how that affects the density, so the overall number of desktops per node, and how that affects the application responsiveness. So if we go from left to right, so a 2 vCPU configuration, take that as the baseline, and then we start to add in vCPUs. Obviously what we do see is there is an increase in application responsiveness. So the blue columns with 3 vCPU, 4, 5 vCPU, we're going to 105%, 106, 107%. So yes, there is an increase, but that comes with a downside in terms of density. So as we're increasing the vCPU count, obviously we are reducing the number of overall resources available for each virtual machine on that node, on that cluster. So what this means in practical terms is we are reducing the baseline count from 100 down to 88 to 81 to 77. So if we want to make the comparison, a 2 vCPU desktop compared to a 5 vCPU desktop running on that same cluster. Yes, that desktop has a bit more performance, but like I said, at the cost of reducing the density by a significant amount. So what is it, 23%. So again, we're reducing the density significantly. So this is why I can go to a customer and say, let's start with 2 vCPUs. Again, if we grouped it into different categories, there may be users that have requirements for unusual configurations. So 10 vCPU machines, or 18 vCPU machines, if they some sort of specialized application. So if we can group those into that user group, we can create a desktop specifically for those use cases. We also look at vendor design and the best practices. So this is based on information taken from the Citrix design guide, so the Citrix VDI design guide, talking about the infrastructure layer. So I mentioned earlier that often gets overlooked. This is talking about all the pieces that are required to be able to run your virtual apps and desktop infrastructure. So your NetScalers, storefront servers, the delivery controllers, I think they're called nowadays. When I used to work there, it was desktop delivery controllers, your database servers, Active Directory design, stuff like that. The three main components you're confronted with in the Citrix world would be your storefront servers, your DDCs, and then the database servers. So again, these are numbers taken from those design guides as a best practice for configuring those virtual machines. So storefront, what does it say? It takes 4 vCPU, best practice configure it with 4 gig memory, and that is going to achieve sort of 600 logon requests or requests to your storefront server per second. So extremely scalable. Your delivery controllers, again, these are numbers from many, many years ago. I remember talking about scalability for your DDCs, and I mean, a single DDC can easily support 5,000 desktops. So a DDC, 4 vCPU configuration, 4 GB memory, 40 gig disk size. The database servers, recommendations here. So for 15,000 users, so a big deployment, we're talking about an 8 vCPU machine, 16 gig memory. And the disk size, it depends really on the databases that we're using. So that in the Citrix world, there's, I think nowadays, there's probably 3 databases at least. It's been a while since I looked. But the disk size of your database servers depends on which pieces we're using. So the monitoring technology, whether using session recording and stuff like that. Then we need to look at CPU strategies. The question here is, do I need more cores or more speed? To be able to understand that, again, it goes back to one of the original statements. Understand the application set. Are those applications CPU bound? Does it require a faster CPU to benefit that application? Are those applications single-threaded, multi-threaded? If they're multi-threaded, a more modern application, I can create a desktop group or a user group for those multi-threaded applications. So that addresses the question, do I need fewer versus more cores? Cost, I really can't comment on that. I mean, the processor prices change daily. So, I mean, this is a chart, it's probably a year old already. But again, the difference here, or the comparison here, is from an 8-core, 3.2 gig machine. So we're talking about 2 vCPU configurations of 51 users per node. And then we're looking at an 8-core, 2.1 gig machine with 75 users per node. The difference is, as it always is in the processor world, the more cores, the lower the clock speed. As a general rule, there are exceptions to that, but this is why it's important to understand, are your applications CPU bound or are they multi-threaded aware? Once we know that, we can then decide on the right processor type for those applications for that user case. Tying that all together into a user for a customer I was working with a couple of months ago. So the requirement there was for 16,000 users. They split it into 2 groups, 6,000 users and 1,000 users and 10,000 users. If we look at the Citrix design guides, they talk about service pods. They'll talk about control resources. They'll talk about user resources, infrastructure resources, stuff like that. So this is essentially from the Citrix VDI design guide. Now the numbers I've taken are assumptions here. So best practice for your fault domain would be 2,000 desktops per cluster. Okay, we can run a lot more per cluster, but if that cluster fails, it's hardware, it's software, I say that often, you lose all your users. So reducing the fault domain down to a tolerable size. Then we're talking about desktops per node. So this is based on some of our internal performance testing. What we're seeing, we saw that number before for task users down to power users, sort of 150 desktops per node. So take that as an assumption. So the resultant cluster size would be 14 nodes for 2,000 desktops. 14 nodes, how do I get to that? So 2,000 desktops, divide that by 150 is about 14 point something. So 14 nodes per cluster. We then need 16,000 desktops. So a cluster size of 2,000 to be able to get 16,000 users is 8 clusters. Putting that all together results in this services pod at the bottom part of the screen. So your VDI infrastructure, so where the actual virtual desktops themselves are running. And in this case, what we see is 8 clusters, so cluster 1 through to cluster 8, and a very simple representation of the nodes in those clusters. In terms of the control pod, so the infrastructure required to be able to run this service pod, we need 3 storefront servers. Okay. Pure maths, we need 2 storefront servers, but we want n+1. 4 desktop controllers. So again, pure maths, 3 controllers is actually enough, but we want n+1, so 4 controllers, and then your clustered SQL servers. So that results in a very simple sizing. So what we have here, like I said, is a services pod with 8 clusters, each cluster running about 2,000 desktops, and each node probably running about 150 desktops. We can then take those numbers and plug those into Sizer and create the bill of materials to be able to get the actual hardware configuration. And like I said, I can do that, or we can go through that in another example when we go through some demos about Sizer itself. So that's sizing, some of the best practices, some of the background information that you need to be able to successfully size these solutions. So let's look at some of the other components, such as optimization. So obviously, Windows 10 comes with a lot of services pre-configured, installed, up and running that are not needed in a virtual desktop infrastructure. So Hyper-V services, why do you want Hyper-V services in the virtual world? Why do you want Xbox services? Specific hardware, so Bluetooth, Wi-Fi, geolocation. I mean, we don't need those. We don't need geolocation for a virtual desktop that is always going to be in the same data center. There's a set of tasks that we can disable. So disk optimization, memory scans, stuff like that. Again, we don't need that in a virtualized world. I mean, the Nutanix architecture is going to take care of all the disk optimizations. If you're not using things such as OneDrive, we can remove that. The Windows Store applications, updates, scheduled scans, like I said, we can manage those with different tools. GPU acceleration. So if we're not using applications, or if those applications don't use vGPU, we can disable those bits, those pieces. And then one thing that's often forgotten is to automate that image building process, but also to reapply those optimizations. If you build an image today on version 1, you then update to version 2 of Windows or whatever, or version 3 of your applications, we then need to reapply that optimization. So again, recheck those that optimization with every Windows build. I'll show you a couple of graphs later on why that becomes important. So there is standard optimization, and then there is real optimization. So not being negative towards VMware or Citrix with their optimization tools. They do a decent job, but it's basic optimization. It's the first step in that process. So again, a comparison between a fully optimized desktop and not being negative, a Citrix optimized desktops. We're seeing a reduction in user density. So when I talk about fully optimized, it's things such as the profile management. There's other technologies out there that can help to fully optimize that desktop. You also need to look at the actual applications in your VDI infrastructure. Again, we can optimize applications and the way that they work. So like I said, there's a big difference between standard optimization or out-of-the-box optimization, and then a more structured approach to optimizing that desktop. When it comes to Windows, so Windows 10, so there's different versions, different build numbers. So again, how this applies to your overall sizing, how this affects the overall sizing. So Windows 10 builds through from, was it 1709 to 2003? So 2017, October through to 2020 and the March release. Is that correct? I think that's correct, yeah. So what we're seeing here, first of all, is the time span where these builds are available. What's important is there are differences between these builds and the resources that they require. So that depicts the life cycle. This depicts how the build affects the overall user density or application performance. So in this case, we're looking at build 1709. Again, take that as the baseline. So 100% user density. As we roll out, or as Microsoft has released different build numbers, the user density has reduced. Why? Because that build has more functions, has more resource requirements. So the message here is the build has or can have a significant impact on your density. So as the builds increase or become more and more modern, that user density reduces. If we look at the application response time, the application response becomes slower for the same hardware. So from 1709 to 1903, the response times of those applications are changing. Again, this affects your overall sizing. We look at the server version. So if you're using virtual apps on Server 2016 or Server 2019, again, a difference in user density. So a reduction here in user density. We look at the application response time. Again, a change in the response time between Server 2016 and Server 2019. So we need to understand, we need to know which versions are being used, which versions you want to deploy, be able to get a better or more accurate sizing. Then look at things such as the display protocol. So this isn't a bake-off between HDX, between PC over IP or BLAST or RDP or whatever. This one is made up numbers, to be perfectly honest, but there are differences in the display protocol. There are also differences in the way those display protocols react under different circumstances. So you cannot just say that ICA is better than BLAST. You cannot just say that ICA is better than RDP. I just said it, I think it is, but that's a different story. There are differences in where and when those protocols are being used. That being said, Citrix have released a blog article a while ago, so talking about the difference of virtual apps and desktops compared to Horizon View. So you could also say essentially it's a difference, or it's a bake-off between ICA HDX and the BLAST Extreme protocol. So what Citrix saw here was a difference in sort of up to 96% more users in a Citrix environment. So the protocol is, so understanding the protocol is essential, again, to sizing these solutions. How do I find out how that protocol reacts? One of the charts at the start, or one of the pieces at the start, was to use performance testing stuff to understand what's actually happening within that desktop. A screen at the end of the slide deck that sort of summarizes all those tools. But the bottom line is, or the message is, the protocol, display protocol, can have a significant effect on the overall density of your VDI deployment on top of Nutanix. I've also mentioned linear scalability a lot of times. Again, this is essential to a successful VDI deployment. So what this chart is talking about is a single node deployment, again using these numbers, 150 desktops per node, and scaling that out to 2 nodes, 4 nodes, 6 nodes, and 8 nodes. So we see a linear increase in the number of users, so going from 150 to 1200. What we also see is a linear line, obviously, a line is linear, is a what we also see is that the response time is linear, or stays pretty much the same across that deployment. So going from a single node machine, purely for benchmark environment, purely for benchmarking, to an 8 node machine, like I said, the response time stays consistent. So 1240 through to the peak is what? 1272 to 1250. So as you increase that cluster, your response time, your user experience, employee experience remains consistent. That said it a few times, a lot of times actually, is essential to a successful VDI deployment. Another way of representing this chart is to look at what happens as those users log on. So as we're ramping up that environment, and then the steady state of when those users, when those employees are actually working. So again, this is consistent. There is a consistent response time, application response time for those users, employees, as they're using this desktop. As the users log off, obviously it tails off. So there is linear scalability across the whole board when those users are actually consuming those resources, doing their jobs. Then the last part of the session, again, this relates to things that happened a couple of years ago. So the Spectre, Meltdown, ForeShadow, so the bugs in the chipsets. But again, the message behind this is there are things that can affect the overall sizing. Again, I've taken these as an example about how that can affect your overall sizing for a VDI deployment on Nutanix. So what we see here is, again, similar sort of story. The difference between the baseline as 100%, so Spectre and Meltdown is disabled. Then we enable that protection. So we're seeing a reduction in density. And then we've enabled the ForeShadow fixes, and that has a further impact on the user density. This is from a couple of years ago. So the Spectre, Meltdown, ForeShadow, again, those things are pretty much rolled into the processes nowadays. So we don't really see those differences anymore. But like I said, the original message was there can be a significant difference between a solution that was sized before Spectre compared to a solution that's sized when Spectre has been rolled up into all the operating systems, bug fixes, and all the processor fixes and stuff like that. Just an example of how things can change your overall sizing. Similar story with application response. The application response degrades. Again, Spectre, Meltdown, and ForeShadow. When we look at processor architectures, so processor generations, so this is an example for a Windows 10 desktop compared to G5, G6, and G7 Intel architectures. Again, G5 being the baseline, 100%, and the response time, again, being 100%. What we see is the session count increases, so we get more users on that desktop, sorry, on that node, so 129%, 170%, so like I said, more density or higher density on the newer nodes. And also the application response time, in this case, a lower number means better, so the applications are becoming more responsive on that more modern architecture. So if you're confronted with a situation, do I go with G6 or G7? So in terms of performance, the G7 obviously is better, user density is higher, application response time is faster. Then when we come to CPU per core configuration, another question that often comes up, do I configure those virtual machines with a single CPU and 2 cores, or 2 CPUs and 1 core, for example? If we look at the bottom line, again, the next 3, so columns 3, 4, and 5. So again, it could be, do I configure it with 1 CPU and 4 cores, or 4 CPU, 1 core, and 2 CPU, 2 core? Ultimately, in these two cases, we have 2 compute units, if you want. What we see is the performance, the user density, is pretty much the same. So configuring your virtual machines for CPUs or for cores doesn't really make any difference. Another example with a 4-core machine. So I know it's confusing in terms of words, but we have 4 compute units if you want. It can be 1 CPU, 4 cores, or the other version could be 2 CPUs and 2 cores. Again, still 4 compute cores. Again, what we see here is the user density is linear, regardless of what that configuration is. So when you're confronted with the question, do I configure CPUs or cores? What's the best recommendation there? It doesn't really matter. Same in terms of application response time. So two compute units or 2 core environments or 4 core environments, we've seen the application response time is pretty much the same, whether it's core based or CPU based. In this case, 4 cores or 4 CPUs or whatever combination you can think up. Then the last piece of the presentation, sort of a summary of some of the tools that we need. So we talked about optimization, we talked about sizing. We didn't really go into monitoring. A few words about that in a few seconds. We talked about graphics. These are tools that you can use to help optimize that virtual desktop. When we look at sizing, these are tools that you can use to understand what's actually happening inside that virtual desktop. When we want to look at the graphics performance, so if you've got vGPU scenarios, again, remote desktop analyzer, GPU sizer, GPU profiler, tools that we can use to understand, like I said, what's happening within that desktop. And then for deployments or deployed systems, like I said, we can use monitoring tools, so Uber Agent, Control App, Desktop Director, tools that every admin should have access to somewhere to be able to help or to be able to ensure that the VDI solutions can be deployed correctly and successfully. So quick summary, get rid of that picture. Quick summary. So sizing isn't black magic. There's a lot of logic behind it. The Nutanix Sizer tool is a good starting point. It is only a starting point. If you know the use cases, if you know the differences between those use cases, we can adapt the Sizer to be able to incorporate all those differences. Use those tools that I just mentioned about, understand the application, so multi-threaded, single-threaded, higher clock rates, CPU frequency sensitive, insensitive, stuff like that. Mentioned this a lot in the presentations. VDI is something we do. So one-click upgrades, one-click expansion. Again, very, very important. Linear scalability as we expand from a few hundred users to thousands of users. The scalability is critical to a successful VDI deployment. And I know it's only a single feature on a matrix somewhere, but this data locality really does matter in a VDI world. If you look at the Citrix concept, when I was there, if you look at the VMware concept, you will never get faster than local storage. That's what data locality basically does. It presents local storage to your virtual machines. As an analogy that I make there is you can have your notebook, you can install Office on the SSD in the machine itself. It's going to run fast. You could plug in a USB drive, you can install Office on there, it's going to run. It's not going to run as fast, but it still runs. So getting that data local to the CPU is critical. Nutanix does that with this data locality stuff. So that being said, that was the 3-part series around end user computing. I'm going to put together another one around a demo on sizing. So we'll go through Sizer with a few examples there. This rocking the socks. So if you've still made it to the end of this presentation, quick word about the rocking the socks or rockasockana. So my little boy's got Down syndrome. Down syndrome awareness is around odd socks. So any customer meeting that I've ever done in my life, I've always had odd socks, never got a matching pair of socks. So that's what the rockasockana is all about. So like I said, keep rocking those socks. Thanks for listening. If you've got questions, you've got comments, feel free to get in touch with me, and have a lot of success deploying your VDI deployments on your Nutanix clusters. Thank you and bye-bye.